guys, welcome to VChem World. Today we will discuss on the various example based on the vapor pressure. First is the an aqueous solution of glucose is made by dissolving 10 gram of glucose in 90 gram of water. So given value is glucose 10 gram and water 90 gram. If the vapor pressure of pure water is 32.8, so given value is the vapor pressure of pure water. So this is the P0 water is equal to 32.8 mmHg. What would be the vapor pressure of the solution? Find out the vapor pressure of solution. So this is the P. Glucose 10 gram and water 90 gram. Given is the aqueous solution. What is the meaning of the aqueous solution? Aqua means the water. Where is the solution made up with the water? It's known as the aqueous solution. In this, glucose dissolved in water. So 10 gram glucose dissolved in 90 gram of water. So small amount is a glucose. So it's act as the solute. And this is the solvent. And this solute is non-volatile. Whereas the non-volatile solute present, so it's not take part in the vapor pressure. So find out the total value of the vapor pressure of the solution. We know that the Raoult's law says that the partial pressure of PA is directly proportional to its mole fraction. So partial pressure of PA is equal to the PA0 in XA. And PB is equal to PB0 into XB. Whereas the A is solute and B is the solvent. And the solvent value PB0 is given. Solvent value PB0 is 32.8. Find out the mole fraction. How to find out the mole fraction? We know that the mole fraction is equal to the number of moles of B divided by the numbers of moles of A plus number of moles of B. So first find out the numbers of moles. So N is equal to the weight by molecular weight. This is the Na and Nb weight by molecular weight. Na is the solute. So solute is the glucose. Its given weight is 10 and its molecular weight 180. Next is the Nb. This is the water. So water 90 divided by the 18. So this is the 5 and this is the 0.056. So numbers of moles of A, this is the solute, is equal to 0.05 and numbers of moles of B is equal to 5. Then find out the mole fraction of the XB. This is the B. So XB is equal to the NB upon Na plus NB. NB value is 5 divided by the 5 plus 0.05. So this is value is the XB. So this value put in this equation, 32.8 into 5 upon 5 plus 0.005. This gives the vapor pressure of the solvent. This gives the vapor pressure of the solvent. But we find out that the total vapor pressure. What would be the vapor pressure of the solution? Solution means the solute plus solvent. So this is the solvent. But in case this is the non-volatile. So non-volatile solute is not take part in the vapor pressure. Because of the non-volatile solute, not its liquid converted into its vapor forms. When vapor form is not produced, so it's not produce the vapor pressure. So this is the non-volatile is the vapor pressure is the 0. That condition only consider is the total vapor pressure is equal to the vapor pressure of the solvent. Total vapor pressure is equal to the vapor pressure of the solvent. So this is the vapor pressure of the solvent PB and find out the total vapor pressure. So this is same as the total vapor pressure. Next is the at 298 Kelvin vapor pressure of pure benzene is 0.256 bar. So given value is the P0 benzene. This is the 0.256 bar. And vapor pressure of pure toluene is 0.0925 bar. So P0 toluene is equal to 0.0925 bar. If the mole fraction of the benzene in the solution is 0.40, so mole fraction of the benzene is equal to 0.40. What is the total vapor pressure of the solution? Total vapor pressure of the solution, that means the total P is equal to PA plus PB. This obeys the Raoult's law. This is the partial pressure of the A and partial pressure of the B. Whereas this is the PB, vapor pressure of the benzene, and partial vapor pressure of the toluene. Find out the total vapor pressure. So this PB is equal to the P0B into XB plus P0T into XT. Because of the partial pressure of the A component A is equal to the pure vapor pressure of the pure component A and its mole fraction. So this is the find out the total vapor pressure of the solution. In this given value is the 0.256 and PT. So PB value is 0.256. Find out the XB plus PT0 0.0925 into XT. How to find out this mole fraction? This mole fraction given value is the 0.40. So this is the 0.40. We know that the mole fraction, always mole fraction total value is equal to 1. So X is equal to the XB plus XT. This value given is the 0.40 and total value always 1. So we find out that the XT value. So XT value is equal to 0.60. Put this value in this equation. So 0.256 into 0.40 plus 0.0925 into 0.60. This is the value of the total vapor pressure of the solution. Calculate the composition of the vapor in terms of mole fraction. We know that in this Raoult's law we find out the mole fraction, but in this case find out the mole fraction in the solution. So this is the Raoult's law. But Dalton's law says that the mole fraction of the benzene or toluene in the vapor phase. How to find out this? So mole fraction of the benzene XB is equal to the partial pressure of the benzene. This is the partial pressure of the benzene upon P total. Same way XT. So this is the mole fraction of the toluene in vapor phase is equal to the partial pressure of the toluene upon P total. P total value is the 0.158 and this is the 0.158. In earlier we find out that the PB and PT value. So put this value in this equation and find out the composition of the vapor in terms of the mole fraction. And dichloromethane at 298 Kelvin are 200 mmHg and 415 mmHg respectively. Calculate the vapor pressure of solution prepared by mixing 25.5 gram of CHCl3 and 40 gram of CH2Cl2 at 298 Kelvin. Find out the vapor pressure of the solution. We know that the vapor pressure of the solution P is equal to the PA. Consider as the CHCl3 plus P is equal to CH2Cl2. Partial pressure of the chloroform and partial pressure of the dichloromethane. And this value 200 mmHg and 415, this is the pure component vapor pressure. So P0 CHCl3 is equal to 200 mmHg and P0 CH2Cl2 is equal to the 415. Then we know that the partial pressure of the P is equal to the P0 into X. This is the vapor pressure of the pure component and X is the mole fraction. We find out that the mole fraction. So mole fraction is find out that is equal to the numbers of moles of A upon numbers of moles of A plus numbers of moles of B. It's before we find out that how to find out the numbers of mole. So mole N is equal to the weight by molar mass. This is find out that the CHCl3. So CHCl3 weight given is the 255 divided by its molar mass, and this is the 119.5. And N is equal to the weight by mass. So this is moles for the CHCl3 is equal to 0.213 and CH2Cl2 this is the 0.473. Find out that the mole fraction. First mole fraction of the CHCl3 is equal to the mole of chloroform divided by the numbers of moles of chloroform plus dichloromethane. N value is the 0.217 divided by the 0.217 plus 0.470. Same way, mole fraction of the dichloromethane, moles of the dichloromethane divided by the moles of the CHCl3 plus NCH2Cl2. This value is the 0.470 divided by the 0.213 plus 0.470. Fraction of the dichloromethane is equal to 0.688. You find out only one value. For example, find out this value 0.312, and we know that the total number of mole fraction is equal to the CHCl3 plus XCH2Cl2, and its value is 1. So this is the 0.312 plus XCH2Cl2. So this gives the same value. So only find out the one value. Then this value put in this equation P0X. So P total is equal to the P0CHCl3X plus P0CH2Cl2X CH2Cl2. This value given is the 200. X value is the 0.312 plus P0CH2Cl2 415 and XCl2Cl2 is equal to 0.688. This given is the total vapor pressure of the solution. Mole fraction of each component in vapor. In the vapor phase, mole fraction is equal to the partial pressure upon the total vapor pressure. Earlier we found that the PCHCl3 is equal to 62.8, 2.4 and 347.9. It gives the 0.18. Next is the mole fraction of the dichloromethane. This is the 0.82. So this is the 0.18 and 0.182. This mole fraction is more. We know that the pressure is directly proportional to the mole fraction. With pressure increase, mole fraction increase, and mole fraction increase, so pressure increase. So this way, this is the mole fraction is more. Where mole fraction is more, so its vapor pressure is more. We know that they find out the mole fraction in vapor. So mole fraction in vapor for the chloroform X is equal to the partial pressure of the chloroform divided by the total pressure. That same way the dichloromethane, partial pressure of the dichloromethane divided by the P total. So this gives the 0.18 and 0.82. This is the vapor pressure is more than the chloroform. Why this is the occur? Because of the mole fraction increase, vapor pressure increase, mole fraction decrease, vapor pressure decrease. So mole fraction increase, so its vapor pressure is 415 mmHg and this is the 200 mmHg. Why this is the more? Because of the, consider as the beaker is the closed system, is the fill up with these two CHCl3 and CH2Cl2. These both are the volatile. But in this case, dichloromethane is highly volatile. Why this is known as the highly volatile? Because of the its pressure is high. Why pressure is high? Because of this liquid converted into its vapor. Where is this liquid is highly volatile, so it's easily converted into its vapor form. Where vapor is more form in this place, so it's produce more pressure and its take part the mole fraction is more. So that way we can say that this dichloromethane is more volatile than the chloroform. X and Y on mixing form an ideal solution. So this is the two liquid X and Y form an ideal solution containing 3 mole of X. So mole of X is equal to 3 and 1 mole of Y of 550 mmHg. So total pressure is equal to the P is equal to the P0X into XX plus P0Y into XY. This is the mole. This is the mole fraction. So find out the first mole fraction. So mole fraction X is equal to the NX divided by the NX plus NY. So NX is equal to 3 plus 3 plus 1. So this is 3 divided by the 3 by 4. Next is the NY. XY is equal to the NY divided by NX plus NY. So this is the 1 plus 4. 0.25 and this is the 0.75. Neither find out the only one value and 1 minus 0.75. So its value is the 0.25. Put this value in this equation P0x, this value is 0.75 plus P0y and 0.25. P total value given is the 550. This is the equation A. Then, but when 4 mole of X and 1 mole of Y are mixed, the vapor pressure of the solution 560. What will be the vapor pressure of the pure X and pure Y at this temperature? Find out that the mole fraction, find out that the vapor pressure of the pure component. So this is the find out P0X and P0Y. Next next condition given is the 4 mole of X and 1 mole of Y. So Nx is equal to 4 and Ny is equal to 1. Same way find out that the mole fraction. So P is equal to the P0x xx plus P0y xy. Xx is equal to the 4 divided by the total. So this is the 4 by 5. This gives the value is the 0.80. Then x is equal to the xx plus xy. 1 into 0.80 plus xy. So this is the 0.20. xy is equal to 0.20. Put in this equation. So P0x 0.80 plus P0y 0.20. This is the equation B. And this total pressure value given is the 560. Then plus this 2, A and B. So first multiply with this 4, A multiply with 4 and B multiply with 5. So it's converted into its integer value. So 550, this with 5. So this gives the value of this. Then minus this 2 value. This is the cancel out and 280 and 200. So this is the minus 600. Highest value sign minus 600. And this is the minus 1 P0x. So Px0 is equal to 600 mmHg value. Then this value put in this equation. This value put in this equation. So we find out that the P by 0. So 2200 is equal to 3. 600 plus P by 0. 220 minus 600, 1800 plus is equal to P by 0. So P by 0 is equal to the 600 value.